1, and it says, what is the starting point for each vehicle? What's the starting point for each vehicle? So let's fill that in. They don't really give us a space for that in the table, so we're going to add it in right up here, okay? So I want you to write starting point, starting point. And let's think about where each of these cars start. And we're looking at where they start in comparison to Flint. So where does the pickup truck start? Where is it starting its journey? In Flint. Yeah, so it'd be 0 miles from Flint because it's in Flint, right? So 0 is what we're going to put for the pickup truck. And then what about the sports car? Where does the sports car start? Oh my gosh. Good, 35 miles from Flint in Saginaw. And then what about the minivan? Perfect. So the sports car is starting 35 miles from Flint, and the minivan is starting 220 miles from Flint. And when they're starting their journey, what is the time? How much time has passed? Good. 0 time has passed when they've started driving, right? Now let's look at, and we'll start with the pickup truck. So the pickup truck is driving 66 miles per hour, right? After 1 hour of driving, how far will the pickup truck be from Flint? Exactly, 66 miles away, right? It's going 66 miles per hour. So after 1 hour, it will have gone 66 miles. So now it's traveling north, so it's going to be like 66 miles away. And then what about after 2 hours? How far will it be from Flint? 132. What about 3 hours? 198. And 4 hours? Good. What did you do to go from number to number like that? Yeah, we just kept adding 66, right? Do you remember what that's called when we have a set of numbers that we add or subtract to go from term to term? It's 2 words. First word starts with an A. Second word starts with an S. Yeah, arithmetic sequence. It's just a set of numbers where each number we're like adding to go to the next one. We're adding the same number every single time. So when we describe an arithmetic sequence, we have to talk about 2 things. We have to talk about the first term, and we have to talk about the common difference. So what's the first term in this sequence? Back it up. 0. And then what's the common difference? How are we going from term to term? That's the 66. Good. Excellent. Okay, let's look at the sports car now. So the sports car starts 35 miles away from Flint, and it's going 48 miles an hour. So after an hour, how far will it be from Flint? Okay. Yeah, how'd you get 83? Perfect. Okay, so then after 2 hours, where is it going to be? And after 3 hours? And 4 hours? Perfect. And let me just show you this on your calculator. I know it's kind of obvious, but I just want to show you this little trick, right? So if I just start with my 35 and I add 48, that's easy enough, right? I just do plus 48 and I hit enter and I get my answer. But then from there, we have a couple little shortcuts, and you might already be familiar with these, but let me just show you anyway. So instead of typing in, I could type in 83 plus 48, right? I could always look and then look back to my previous answer, type in that answer, and then add on from there. Or if I just press the plus sign, it shows up as ANS, that's answer. So it pulls the last answer and it automatically just grabs it. And so all I have to just hit is plus 48. And then I hit enter and I get that 131. But then from here, now that I've done it twice, the calculator recognizes the pattern. And so all I have to do is just hit enter and the next answer will come and then the next answer will come, right? So if I just keep hitting enter, it's going to just keep adding on automatically. All right, and then let's look at the minivan. Oh, actually, if we look at the sports car as an arithmetic sequence, what is the first term of that sequence? Good, 35. And what is the common difference? 48. Good. And now let's look at the minivan. So the minivan's driving 72 miles an hour. And it started at 220. So where's it going to be after an hour? Yeah. So I got a couple people saying 292, and I have David who says 148, right? Which one's it going to be? Yeah, exactly. Exactly. So, right, he's starting at the Mackinac Bridge, and as he keeps driving, he's going toward Flint. So the distance to Flint is going to keep getting smaller and smaller and smaller, versus the other people that were going away from Flint, so the distance keeps getting bigger and bigger. So yeah, so we're going to subtract 72. We're going to subtract 72. So we get 148 after 1 hour. What about after 2 hours? Where are they? 76 miles away. What about after 3 hours? And then what happens at 4 hours? So what happens? Did he go underground? They went past Flint, 68 miles, which is like right about where I grew up. It's like 68 miles south of Flint. So that negative sign just means that they went past Flint. They kept driving past Flint. And if we talked about our minivan as an arithmetic sequence, what is the first term of that sequence? And the common difference? Good, negative 72. Negative 72. Right, when I had the positive common difference, my relationship is increasing. When I have the negative common difference, it's a decreasing sequence. So now we're going to take this table, and just like we did yesterday, we're going to convert this table into a graph. So you should have grabbed the Wednesday paper as well. If you didn't grab the Wednesday paper, you should now. And I'm going to pull this up on here. You have some colored pencils at your desk. You also have some rulers at your desk to help you out. Just a minute. Okay. And paste. Tool select over here. All right. So let's go ahead and we're going to graph the pickup truck together. Graph the pickup truck together. So actually, let's talk about this first. So I know I have like 4 columns in this table, right? But I only have 2 variables that I'm looking at. What are my 2 variables that I'm looking at? Good, distance and time. And how am I measuring the distance? Good, miles. And how am I measuring time? Good. And which variable is distance going to be, X or Y? Good, Y. And that's going to make my time the X variable. Good. So this table has a whole bunch of X values. not a whole bunch. We just have 0, 1, 2, 3, and 4. Those are my different x coordinates I'm going to use. And then all of these are going to be my different y's. So I have 3 different y's I'm going to use. So let's go ahead and again we'll plot our pickup truck together. So I'm going to start at time 0. When the time is 0, the distance from Flint is 0. So that's my first point for the pickup truck. And then after an hour, the pickup truck is going to be 66 miles from Flint. So after an hour, I go right to the 1, and then I need to go up to 66. And my graph is counting, it's only counting by 50s, but all of these little hash marks are just an extra 10. So this is like 60, 70, 80, 90. So 66 has got to be right in between 60 and 70, so about right there. And then at the second hour, pickup truck is 132 miles away, so that's going to be up here. This is 110, 120, 130, so just above the 130 mark, right above the 2, so about right there, right? At the 3-hour mark, they're at 198 miles from Flint, so 3 hours is about 198, which is just a little bit less than 200. And then at 4 hours, they're 264 miles away, which my graph only goes up to 220, but I could imagine, 264 is probably right up there somewhere. Now I have these points on my graph. What shape do the points make? Good, a straight line, right? What do I call a graph or a relationship that has a straight line? Good, it's a linear relationship. Very good. Linear, good. And again, we could label this. We could call it, I could just write pickup truck so I'm not getting confused. And then I'm going to have you guys draw the graphs for the sports car as well as for the minivan. Sports car and the minivan. And I'm going to come around in a couple minutes and check and see how you're doing. Don't forget about this starting amount, that first little row that we did together. Okay. All right. So I've got the graphs up here on the board in case you didn't finish, but I think pretty much everybody finished. Right, and I've got my pickup truck in blue, my sports car in red, my green minivan. Let's talk through step 6. So step 6 says, where do the starting points show up on our graph? Where do the starting points show up on the graph? Good, on the y-axis, right? I've got my pickup truck starting at 0, sports car starting at 35, minivan starting at 220. So they show up on the y-axis. Okay, and it's our starting points. Our starting points are represented by those points. And what do we call those points? The point where the graph intersects with the y-axis. What do we call that? Where does the graph cross the y-axis? Not the x-intercept, but the, exactly. So the starting points are represented by the y-intercepts. No. Yep. Kayla, you repeat. Okay, and then it asks, how does the recursive rule relate to the plots pointed? So, like, let's just look at the pickup truck. And I kind of explained this a couple of times. The recursive rule means this like repeated operation. What are we doing over and over and over again? So for the pickup trip, we kept adding 66, adding 66, adding 66. How does that like plus 66, where does that show up on my graph? The what? Yeah, it's like the y value changing, right? So every time I go over 1, I'm going up 66, right? Up 66 over 1. Going up 66 over 1. Up 66, right? Over 1. When I'm talking about going up and over, what am I talking about? Good, that's my slope. So the recursive rule, my common difference, what I'm adding every time, is my slope, is the slope. Does that make sense, Kaya? More so than what I said earlier. Good. Okay. And so number 7, step 7, I labeled it right there. But how would we know that that green line is the minivan? It's decreasing. It's the only one that's decreasing, right? It's the only one that has a negative slope. It's because it's going in the opposite direction. What did you say, David? Yeah, right. If you were colorblind, you could still tell because it's the only one with that negative slope. It's the only one going in the opposite direction. All right, so step 8 says estimate where all 3 vehicles are when the minivan meets the first northbound vehicle. I'm going to check this in just a second. So I want you to tell me 3 things. Which car does the minivan meet first? Which car does the minivan meet first? And then I want you to tell me when and where do they meet? Okay, which car does the minivan meet first? When do they meet and where do they meet? Okay, and then if you finish number 8, keep going to step 9, 10, 11, 12.
many miles away from Flint are they? How long have they been driving? And then getting to the first spot. And what is the first part of it? And then you put the numbers in as a ordered pair, which is really good. And then tell me what do the two numbers mean. How did you know where they are? So that's your one variable. So the destination, so the destination minivan would be Flint. So when did they get to? And then the truck and the sports car was trying to get to which one? And then
So which car is the minivan going to meet first? Yeah. Yeah, the sports car, right? The minivan. We're always looking left to right, right? And if I just follow the minivan down, I can see it's going to cross that the red line first, the sports car first. And that point right there, that point has an ordered pair, doesn't it? X and Y. What is the X coordinate of that point-ish? Yeah, about 1.5. And what is the Y coordinate of that point? Yeah, 110. So what does the 1.5, what is that referring to? Yeah, it's the time. So after they've been driving for an hour and a half, the sports car and the minivan meet when they are 110 miles away from Flint. Okay, good. So that's number 8. Number 9, which is number 9, ask us. Ooh, how can you tell that the pickup truck is going faster than the sports car by looking at the graph? Perfect, yes. So the slope for the pickup is 66 over 1, but the slope for the sports car would be 48 over 1. So the slope for the pickup truck is steeper. That tells me that it's going faster, that steeper slope. And then we have in number 10, which car is going to get to their destination the fastest? Yeah. So their destination, the destination of the minivan, they're trying to get down to 0. So I can see the minivan gets to 0 at about 3 hours and like 4 minutes or something, maybe 5 minutes. The sports car and the pickup truck.
Can we have Thompson Root come to the office, please? Thompson Root?
The pickup truck and the sports car are both trying to get to the 220 miles, right, to the bridge. And the pickup truck gets there at about 3 hours and 20 minutes, and the sports car doesn't get there until 4 hours after they leave. So, of course, then the minivan is going to get there the fastest, right? Gets there 3 hours, just over 3 hours. And then number 11 asks, what assumptions are we making about this? That they have a constant speed. Is that realistic? No. When you go for a road trip, if you drive for really any amount of time, you're very rarely going to go the same exact speed the entire time, right? Even if you put cruise control on and you're pretty much going the same speed most of the time, someone's going to go in front of you, you're going to have to slow down, you're going to have to get off and get snacks or whatever, right? So we're assuming that there's this constant speed the whole time, but in reality that probably wouldn't happen. However, the constant speed makes the graph a lot easier and prettier to deal with. Yeah. Like someone not from this class?
Yeah.
You don't know who they were?
No.
Why?
When I got out of the stall, it was gone. I was like, why would you take that?
That's like the third hall pass already. That's really annoying. And actually, yeah. Okay. Well, if you come across that purple ruler, it says my name on it, maybe they'll be kind enough to give it back, but thank you for telling me. Did someone have something else they were going to say about this? Someone said something. No? Okay. That's all we have. We're all done. Okay, you can put those papers in your folder. I'm going to hand back your tests to those of you who have taken the test. If you haven't taken the test yet, you need to come in at lunch and get that done. Okay, then apparently someone took the hall pass out of the bathroom. Who did? Yeah. Yes. That's okay. So again, if anybody sees it, bring it back. I know. Thank you, and I'm sorry that happened. Yeah. I could find another random object, I'm sure, that we could use. I don't want that monkey to be all gross in the bathroom, though. No, not like I can with a ruler, right? That's like fabric, and I feel like it's gonna get creepy. A pen? I feel like that's too small. That's true. Like a lanyard. Anyway, it's okay. A hat? That would be bad. I've used hand sanitizer before, and then it's like, can't get gross. So you can use the hand sanitizer on your hands.
No, I was thinking why was someone still hall pass 3 times?
I don't know. Well, the second one, it wasn't stolen, it was just shattered. But the first one and the third one were stolen. And now I feel like it started happening, so now people are going to continue doing it just to tick me off.
Reminds me of something. Middle schoolers.
Yeah, I've never dealt with this before. I had that Black Panther hall pass for like 3 years. Okay, I'm going to hand back your tests, you guys. I do need these tests back when you're done looking at them. Again, if you got less than a 60%, you'll need to retake it during lunch. If you haven't taken the test yet, you'll need to take it during lunch.
those are quizzes. Yeah, I'm okay. I'm just being really clumsy today. I like fell off earlier. No, you need to turn them back into the inbox when you're done looking at them. What numbers? So there are 18 that are on this side. Oh, 19. But that's not what I did. I did. No, I don't get extra credit on tests. No, you give them back. Please, Lily, you can keep these quizzes though. What? The test.